Well, hey everyone, and welcome back. In this video we'll be covering two topics that are relevant to unconformities, but don't exactly fall into the category of an exact type of unconformity. So the first one that we have here is overstep. And all that overstep is it's when you've got a pre-existing older strata onto which a younger strata of different dip is placed. So you'll have usually several strata all dipping in the same direction until some erosion occurs. And then you'll have some younger strata placed on top of it, and these ones will be dipping at a different angle after they are deposited. So that's our way of telling when there is an overstep. And what this looks like, you kind of have to look at it in 3D. You can't just use a two-dimensional cross-sectional diagram. So I've got this block diagram here set up. And this piece right here, this is where our overstep is going to be. That line right there. And let's just say we've got some layers here. Down in the ground. Give them slightly different looks. That one can just be white. And then they carry over here. We'll say they go like that. And then let's say we've got two pieces in here. Sort of run out of ideas for design, so we'll just call these X and Y. So these layers were the ones that were originally deposited, and then some erosion occurred that allowed for this section of the block to become open to new deposition, which is when X and later Y were deposited on top of them. And you can also see that the dips of these rocks, they're dipping downwards like this. Meanwhile, X and Y are at a completely different angle. Same thing on this side. They're completely different angles, which means they have different dips, and therefore it is an overstep. And when we look at the overstep, we always define the overstep as being right here, where the farthest reach of whatever strata you have, or in this case X, when the farthest reach of your youngest strata touches some originally deposited strata. And actually this would look something like that. Once again, you can tell they're dipping differently because these are at entirely different angles. These two meet at almost a right angle. And that's all there really is to an overstep. The next topic is overlap. Now, a piece of information that's essential to understanding overlap is the concept of subsidence. And subsidence is just when you have this rising sea level, such that the ground moves down relative to sea level. Now, how this pertains to geology is that when the water rises, typically a lot of sediments are deposited, which allows for new strata to be formed on top of currently existing strata. Subsidence is always followed by uplift, which is as the water sinks, the ground moves up, hence the name. And this usually is marked by erosion, which creates many unconformities. But imagine, let's say that as the water is moving up, more and more sediment is being deposited. And you can imagine it as continuing to move up this sort of block diagram, further and further. Now you'll recall that in the last block diagram, we had something that looked kind of like this. I'll just draw this sort of off to the side. We had a similar shape a sort of a triangular prism here. But what we had was, we had x here and y here. Now y is this layer down here, x is this layer up here. And you can tell that because y rests on top of x at this point, that y is younger and it was deposited after it. But what if we had so much subsidence that y actually overtook x and stretched, after x was deposited, we had more deposition of the sediments that form strata I, y, such that this boundary was stretched beyond where x is. Well, that's what this would look like, and that's essentially what overlap is. You have so much subsidence that the boundaries of y keep, or whatever you call your newest layer of strata, they keep on expanding such that they overtake the one directly beneath it. So what that would look like is we would have, this would all just be y, right? You could only, at the top, at ground level on the surface, you could only see y. However, x still exists because down below, we'd have something like this. Y would sort of stretch out like that, and then come around like this. And you can only see x down here. And this surface right here where we see y just pretty much going over x. Usually it'll be more defined than this, my drawing isn't perfect. But this surface right here where we see the contact down there, that is the overlap. And why is this related at all to unconformities? Well, because an unconformity has to exist due to erosion, due to the initial uplift in order for such subsidence to occur. So if we were just to fill out the rest of this block diagram here, we don't have to be super detailed, but let's just say we've got some layers down here. We'll call that layer A, that layer B. And then they sort of stretch out like this. A goes up like that, and maybe B's tilting upwards like that. So they're, once again, they're at a different angle, and so this right here would be a plane of unconformity. And in this case it would be an angular unconformity. And once again we'd have small layers up here. Once again at different dips from y and x, to show that yes, these strata are completely uneven, and therefore there is an unconformity. In order for this to occur, you must have an unconformity first. If you just have flat layers of strata on top of each other, well, no overlap can really occur because you're not going to have this weird sort of angle going on here. You would just, you can't overlap a flat surface when you're already on top of a flat surface. That's just called normal deposition, right? Well, I hope that made sense. Hopefully it was informative, otherwise good review. And I will see you in the next video.